Hi all, welcome to Nursing Diaries. In this video, we will be discussing about inferential statistics. Inferential statistics are concerned with populations and use sample data to make an inference about the populations or to test hypotheses. Inferential statistics are concerned with making inferences based on relations found in the sample to relations in the population. Inferential statistics helps us to decide, for example, whether the difference between groups that we see in our data are strong enough to provide support for our hypothesis that group difference exists in general in the population. We will start by considering the basic principles of significance testing such as null hypothesis and alternative hypothesis, confidence interval, type 1 and type 2 errors, p-value and level of significance. Then we will consider a large number of statistical tests and techniques that help us make inferences for different types of data and different types of research designs. Let's move on to each one. First one, we will discuss about null hypothesis and alternative hypothesis. A hypothesis is an approximate explanation that relates to the set of facts that can be tested by certain further investigations. There are basically two types, namely null hypothesis and alternative hypothesis. These hypotheses provide the researcher with some specific restatements and clarifications of the research problem. The null hypothesis is generally denoted by H0, which states that there is no exact or actual relationship between the variables. The alternative hypothesis is generally denoted by H1, which states that there is a statistical significant relationship between two variables. Let's move on to confidence interval. The confidence interval is a range of values that's likely to include a population value with certain degree of confidence. It is often expressed in percentage, whereby a population mean lies between an upper and lower interval. For example, in this picture you can see that the probability of the population mean value being between minus 1.96 and plus 1.96 standard deviations from the sample mean is 95%. You can see the confidence interval which is set based on the Z score in this chart. Why do the researcher use confidence interval? It is more or less impossible to study every single person in a population. So researchers select a sample or subgroup of the population. Therefore, a confidence interval is simply a way to measure how well your sample represents the population you are studying. Let's move on to type 1 and type 2 errors. In the context of testing of hypothesis, there are basically two types of errors we can make. A statistically significant result cannot prove that a research hypothesis is correct because a p-value is based on probabilities. There is always a chance of making an incorrect conclusions regarding accepting or rejecting the null hypothesis. Anytime we make a decision using statistics, there are four possible outcomes with two representing correct decision and two representing errors. In this picture, you can see four decisions which we can make in the conclusion of a research. The type 1 error, also known as error of the first kind, occurs when the null hypothesis is true but is rejected. A type 1 error may be compared with so-called false positive. A type 1 error occurs when we believe a falsehood. The rate of the type 1 error is called the size of the test and denoted by alpha, so it is also known as alpha error. It usually equals the significant level of a test. If type 1 error is fixed at 5%, it means that there are about 5 chances in 100 that we will reject null hypothesis when it is true. One of the most common approaches to minimize the probability of getting a false positive error is to minimize the significance level of a hypothesis test. For example, the significance levels can be minimized to 1% or 0.01. Next is type 2 error. Type 2 error, also known as error of the second kind. It means that accepting the hypothesis which should have been rejected. A type 2 error may be compared with so-called false negative. A type 2 error is committed when we fail to believe a truth. A type 2 error occurs when one rejects the alternative hypothesis, when the alternative hypothesis is true. The rate of the type 2 error is denoted by Greek letter beta, also known as beta error, and it related to power of a test. We can reduce of committing a type 2 error by using descriptive testing and ensuring that the test has enough power. This may be possible by increasing the sample size. Next, we will see level of significance or p-value. The level of statistical significance is often expressed as p-value between 0 and 1. The smaller the p-value, the stronger the evidence that you should reject the null hypothesis. A p-value less than 0.05 is statistically significant. It indicates strong evidence against the null hypothesis, as there is less than 5% probability the null is correct. Therefore, we reject the null hypothesis and accept the alternative hypothesis. A p-value higher than 0.05 is not statistically significant and indicates strong evidence for the null hypothesis. This means we retain the null hypothesis and reject the alternative hypothesis. Next, we will move on to statistical test. These are intended to decide whether a hypothesis about distribution of one or more populations should be rejected or accepted. The statistical test mainly divided into parametric test and non-parametric test. A parametric test is a kind of hypothesis test which gives generalization for creating records about the mean of the original population. This type of test includes studentttest, ANOVA, etc., which assume data is from a normal distribution. Next, we will see non-parametric test. The non-parametric test does not require any distribution of the population, which are meant by distinct parameters. It is also a kind of hypothesis test that is not based on the underlying hypothesis. In the non-parametric test, the test is based on the difference in the median. So this method of test is also known as a distribution-free test. The test variables are determined on the ordinal or nominal level. If the independent variables are non-metric, the non-parametric test is usually performed. Let's see some of the differences between parametric and non-parametric test. In parametric test, it always based on assumed normal distribution. Whereas in the case of non-parametric test, no assumed shape or distribution. The value of central tendency here in parametric test, mean value is used. Non-parametric test, median value is used. Correlations, mainly Pearson's correlation is used, and in non-parametric, Spearman's rank correlations are used. Probability distribution is normal in parametric and arbitrary in non-parametric. Population knowledge is required in the case of parametric, which is not required in the case of non-parametric. In parametric test, it mainly handles the quantitative data such as interval data and or ratio data, whereas in the case of non-parametric test, it handles qualitative data such as ordinal data or nominal data. Mainly applied in variables, whereas non-parametric test mostly applied on attributes and variables. Examples of parametric test are t-test, z-test, ANOVA, etc. In non-parametric test, Kruskal-Wallis and Mann-Whitney U-test. The parametric test have more statistical power, whereas non-parametric test not so powerful like parametric test. Let us see the commonly used parametric test. First one is t-test. It is applied when the number is less than 30. It is mainly classified into t-test for one sample and t-test for two samples. The t-test for two samples again divided into two, unpaired t-test and paired t-test. Next one is Pearson correlation, and next one is z-test for large samples. When the number of samples increases more than 30, we use z-test. Last one is ANOVA or analysis of variances. It is again divided into two, one-way ANOVA and two-way ANOVA. Let's move on to each one. First one is t-test, also known as student's t-test. It is developed by Professor W.S. Gossett in 1908, who published statistical paper under the pen name of student. Thus, the test is known as student's t-test. The student's t-test is a method of testing hypothesis about the mean of a small sample drawn from a normally distributed population when the population standard deviation is unknown. The t-distribution can also be used to construct confidence interval for the true mean of a population. Let's move on to assumptions made in the use of t-test. First one is samples are randomly selected. The quantitative data are used in the t-test. Variables follow normal distribution. The sample variances are mostly same in both the groups under the study. Samples are small, mostly lower than 30. A t-test compares the difference between two means of different groups to determine whether that difference is statistically significant. Student t-test used for different purposes. T-test for one sample, t-test for unpaired two samples, and t-test for paired two samples. First, we will discuss about t-test for one sample or one sample t-test. It is used to compare the mean of a single group of observations with a specific value. In one sample t-test, we know the population mean. We draw a random sample from population and then compare the sample mean with the population mean and make a statistical decision whether the sample mean is different from the population. The formula for the one sample t-test is t equal to x bar minus mu all divided by s divided by square root of n. Here x bar is the sample mean, mu is the population mean, and s is the sample standard deviation, and n is the number of observations. If absolute value of t obtained is greater than the table value, then it rejects the null hypothesis. And if it is less than table value, the null hypothesis may be accepted. Let's move on to one exercise. Your company wants to improve sales. Past sales data indicates that the average sale was $100 per transaction. After training your sales force, recent sale data, which is taken from sample of 25 salesmen, indicates an average sale of $130 with a standard deviation of $15. Did the training work? Test your hypothesis at 5% alpha level. In the first step, we have to state the null hypothesis, which states that there is no difference in the sales. The second step, we have to state the alternative hypothesis. It states that there is a difference in the sales. That means the sale is increased. Next step, we have to identify the values from the given question. Here, the sample mean is 130, population mean is 100, sample standard deviation is 15, and number of the observations are 25. Then we have to apply it into the formula which is given. T equal to x bar minus mu all divided by s square root of n. When we apply the values, we will get 130 minus 100 divided by 15 divided by square root of 25. That is 30 by 3 and we get a value 10. So that's the t value what we get. The next step is we have to find the table value. The alpha level which is given here is 5%. Then we have to calculate degree of freedom, which is the number of items in the sample minus 1. Here it is 25 minus 1, that is 24. So that's the degree of freedom. Next we have to look up 24 degree of freedom in the table. From the table here we can see that the intersection is 1.711. So that's a one-tailed critical t value what we got. The calculated t value, that is 10, is greater than the table value, that is 1.711. Thus, the null hypothesis rejected and accepting the alternative hypothesis. So we can conclude that there's a difference between the sales. That means the sale is increased and the training is effective. Next, we will move on to two-sample t-test. First, we will discuss about unpaired two-sample t-test. Unpaired t-test is used when we wish to compare two means. It is used when two independent random samples come from the normal populations having unknown or same variance. For example, suppose that we have measured the weight of 100 individuals, 50 women in group A and 50 men in group B. As it is a hypothesis testing, here also we will see whether the null hypothesis or alternative hypothesis which is accepted. Let's move on to assumptions. The samples are random and independent of each other. The distribution of dependent variable is normal. The variance are equal in both the groups. Let's see paired two-sample t-test. It is used when we have paired data of observations from one sample only, when each individual gives a pair of observations. Same individuals are studied more than once in different circumstances. Measurements made on sample people before and after interventions. Example, students test results before and after a particular module or course to see the significant differences. The assumptions of paired two-sample t-test are the outcome variable should be continuous, the difference between pre and post measurements should be normally distributed. To find out the unpaired and paired t value, we use the formula t equal to x1 minus x2 all divided by square root of s1 square divided by n1 plus s2 square divided by n2. Here x1 is the mean of sample 1, s1 is the standard deviation of sample 1, n1 is the sample size of sample 1, x2 is the mean of sample 2, s2 is the standard deviation of sample 2, and n2 is the sample size of sample 2. Let's see the steps for interpreting t-test results. In step 1, we have to state null hypothesis and alternative hypothesis. Next step, we have to identify the given values. After that, we have to put the values in the equations and find t value. And thereafter, we have to compute the degree of freedom. Here, when we compute the degree of freedom, For unpaired samples, the DF will be calculated as n1 plus n2 minus 2. For paired samples, DF will be calculated by deducting 1 from the number of samples, that is n minus 1. And the next step, we have to identify the table value of t distribution using DF. And the last step, to compare and interpret using the calculated t value with table value. So here, if the t value is higher than the table value, that indicates null hypothesis rejected and alternative hypothesis accepted. If the t value is less than the table value, null hypothesis will be accepted and the alternative hypothesis will be rejected. Let's move on to exercise question. So here, a percentage of cartoon labeled as funny by 4 women and 5 men. Find the significance. Either men or women are more likely than the opposite gender on average to find the cartoon funny. So here we have to state that whether men or women who are more likely than the opposite gender on average to find cartoon as funny. So we have to see whether any statistical difference between both the gender. As the first step, we have to state the null hypothesis and alternative hypothesis. Null hypothesis states that there is no significant difference between men and women to find the cartoon as funny, whereas alternative hypothesis states that there is a significant difference between men and women to find cartoons as funny. So we have to make a table and we have to identify mean, standard deviation and n value from the given data. So we have identified, then we have to apply into the formula. So after applying the formula, we got a value of 0.03. So that's the t value, calculated t value what we got. The next step is to calculate degree of freedom. As it is an unpaired sample, the DF will be calculated using the formula n1 plus n2 minus 2. So here it is 5 plus 4 minus 2, 7, which is DF. So the next we have to identify the table value for 7 DF at p value 0.05. The table value which is calculated to be 2.37, which is higher than the calculated t value. And here the null hypothesis is accepted. So we can say that there is not enough evidence to conclude that either men or women are more likely than the opposite gender on average to find the cartoons funny, or there is no significant difference between both the gender to find the cartoon as funny. Let's move on to another exercise. Find, is there any significant change in mood after an intervention among 9 students? So here it is a paired group. So first one, we have to state the null hypothesis, which is there is no significant change in mood after intervention. An alternative hypothesis states that there is a significant change in mood after intervention. Next, we have to arrange the given data into a table and we have to find out mean and standard deviation. Next, we have to apply the values into the formula. And finally, we got a value of minus 2.94. Next step is to calculate degree of freedom. As it is a paired samples, here we are using the formula DF equal to n minus 1. So we got a DF of 8. Then we have to identify the table value of 8 DF at p value 0.05. The table value is calculated to be 2.31, which is less than the calculated t value, and the null hypothesis rejected. So it states that there is a significant change in mood after intervention. Next parametric test is Pearson's correlation. Pearson's correlation coefficient is the test statistics that measures the statistical relationship or association between two continuous variables. It gives information about the magnitude of the association or correlation as well as direction of the relationship. Next parametric test is ztest. Ztest is also a hypothesis test in which the Z statistics follows a normal distribution. As the sample size increases, the t distribution approaches the bell shape of the standard normal distribution. In practice, for tests involving the mean of a sample size greater than 30, the normal distribution is usually applied. Details regarding ztest and or normal distribution is mentioned in the previous video and the link is given in the description. The next parametric test is analysis of variance or ANOVA. It is given by Sir Ronald Fisher. Principal aim of statistical model is to explain the variation in measurements. The student's t-test is used when two independent groups groups are compared, while the ANOVA extends the t-test to more than 2 groups. The ANOVA is also appropriate when there is more than one explanatory factor in which a multi-factor ANOVA may be used. ANOVA models may be parameterized in several different ways. Let's move on to assumptions of ANOVA. First one is sample populations can be easily approximated to normal distribution. All populations have same standard deviation. Individuals in the population are selected randomly. Independent samples are used. ANOVA compares variance by means of simple ratio called F ratio. F is the ratio of variance between the groups and variance within the groups. The fundamental strategy of ANOVA is to systematically examine variability within the group being compared and also examine variability among the groups being compared. The resulting F statistics is then compared with critical value F obtained from the F tables in much the same way as we have done with the T. Same like in t-test, if the calculated value exceeds the critical value of appropriate level of alpha, the null hypothesis will be rejected. In ANOVA, the F-test is used to establish whether a statistical significant difference exists in the data being tested. The ANOVA can be of two types, one-way ANOVA or two-way ANOVA. A one-way ANOVA is used if the various experimental groups differ in terms of only one factor at a time. For an example, a study to assess the effectiveness of 4 different vaccines on COVID-19. In the case of two-way ANOVA, it is performed if the various groups differ in terms of 2 or more factors at a time. For an example, a study to assess the effectiveness of 4 different vaccines on COVID-19 in 3 different age groups. In that case, we apply two-way ANOVA. To conclude, test of significance plays an important role in conveying the results of any research, and thus the choice of an appropriate statistical test is very important as it decides the fate of outcome of the study. So this is all about parametric test. In next video, we will be discussing on non-parametric test. Thank you so much for watching. Please subscribe and support. Have a nice day.